This is the first lesson in our Python object-oriented programming course. Today, we're going to answer a simple but powerful question. What is object-oriented programming and why should you care about it? Have you ever written a Python script to track things, maybe books or users or tasks, and as you added more features, it turned into a huge mess? Suddenly, your code is hard to read and almost impossible to extend. That's where object-oriented programming comes in. Let's give another concrete example. You're building a simple script to track books you read. It works, but then you want to sort them, tag them, share reviews, save them, and connect to an API. Suddenly, your code becomes spaghetti. Object-oriented programming is the secret weapon to keep your code clean, modular, and scalable. So, what exactly is object-oriented programming? Here, OOP stands for Object-Oriented Programming. It's a style or paradigm of writing code where you organize everything into objects. Think of objects as building blocks. Each block bundles together data, which are things the object knows, and behaviors, which are things the object can do. For example, if you were coding a program about cars, you would create a car object that knows its color, brand, and speed, and it can drive, brake, and honk. Why should we use object-oriented programming, and why do developers love it? It's because it makes your code more organized or modular. That is, you can break your program into small independent pieces called classes or objects. This makes it easier to manage, easier to debug. That is, if something goes wrong, you know exactly where to look because every class is self-contained. You don't have to dig through hundreds of lines of tangled code. Simpler to use and extend. Here, reusable means that once you create a class, you can use it again and again in different parts of your program or even in different projects without rewriting the logic. And extensible means that when you need to add new features, you can extend existing classes or create new ones without breaking everything else. This makes your program grow naturally, like adding new rooms to a house. So, object-oriented programming is all about organizing your code into objects. It's the secret to writing programs that are cleaner, easier to maintain, and ready to grow as your needs change. To understand object-oriented programming, let's go back to the example we gave before. Imagine you're building a program that deals with cars. Instead of writing scattered pieces of code to track each car's color, brand, and speed, you create one blueprint called a car. This blueprint, or class, describes what every car has and what every car can do. So, what does a car have? Each car has properties. For example, a color, a brand, and a speed. These properties describe the state of the car. Each car also has behaviors. For example, it can drive, brake, and honk. These actions that belong to the car are also called methods. How it works in object-oriented programming. In object-oriented programming, you create this car class once. Then from that class, you can create many individual cars called objects, like red Mercedes, black Tesla, or a blue BMW. Each car object keeps track of its own data, that is, its color, brand, and current speed. But they all share the same blueprint. Why is this powerful? This is powerful because now, instead of writing messy code for every single car, you just create new object from the car class and they already know how to drive, brake, and honk. This is the beauty of object-oriented programming. You write code once and reuse it as much as you want. So remember, a class is like a blueprint, and an object is like an actual car built from the blueprint. This is exactly how object-oriented programming organizes your programs in a clean and logical way. To really understand the power of object-oriented programming, let's compare how coding looks without object-oriented programming and with object-oriented programming in 4 common situations. The first one is building apps. Without object-oriented programming, when you build apps, you often end up with spaghetti code everywhere, that is, functions and variables scattered all over the place. With object-oriented programming, your code is structured into reusable objects, making it neat and easy to manage. The second one is reusing code. Without object-oriented programming, reusing code means copy-pasting functions from one file to another, which is messy and error-prone. With object-oriented programming, you can use inheritance and methods reuse. So you write code once and use it everywhere. The third one is scaling. Without object-oriented programming, scaling your program is a nightmare. When you add new features, everything breaks because your code wasn't designed to grow. With object-oriented programming, you can extend classes cleanly, add in new features without rewriting everything. Working in teams, which is the fourth one. Without object-oriented programming, when multiple developers work on the same project, there are conflict and confusion because no one knows where things belong. With object-oriented programming, there is a clear structure and clear rules for each part of the code, so teamwork becomes much easier. This is why object-oriented programming is such a powerful way to write code. It keeps things organized, reusable, and scalable, and makes team collaboration far more efficient. Now, while object-oriented programming is a powerful tool, it's important to know that you don't always need it. Sometimes using object-oriented programming can be overkill. So, when should you skip object-oriented programming? Use simple procedural code when you are writing small, quick script. For example, if you just need a one-off script to convert some files or print a report, object-oriented programming isn't needed. Object-oriented programming is not needed when your code doesn't need to be reused or scaled. If you're not planning to extend or maintain it later, procedural code is fine. Object-oriented programming is not needed when you want simple automation. For example, renaming files in a folder or doing a quick CSV processing task. You can write a few functions and be done. So remember, object-oriented programming is amazing for building large, reusable, and scalable programs. But for small one-time script, sticking with simple procedural code can actually save you time. Here's an easy way to decide whether to use object-oriented programming or not. Use procedural code when it's one and done. If your script is small, quick, and won't need future updates, just keep it simple. But use object-oriented programming when your program is meant to grow. If you plan to add features, reuse code, or scale the project later, object-oriented programming is the way to go. Think of it as choosing the right tool for the job. Simple tools for small tasks, object-oriented programming for big, evolving projects. Let's wrap up what we have learned in this lesson. First, object-oriented programming is not just about learning some new syntax. It's a mindset, a way of thinking about how to structure your programs. Second, Object-oriented programming helps you model the real world in code. You can represent things as objects with their own data and behaviors, making your programs feel natural and organized. Third, use object-oriented programming when you want to scale, reuse, or organize your programs. It's perfect for larger projects that need to grow over time. Finally, remember you don't always need object-oriented programming. Start small with procedural code when it's simple and grow into object-oriented programming when your project demands it. Great work! You now understand what object-oriented programming is and when to use it. This foundation will make the rest of the course much easier to follow. So, what's next on your object-oriented programming journey? In the next lesson, we are going to take things a step further and dive into classes and objects. You will learn how to create your very first Python blueprint and then use that blueprint to build real objects in your code. So, get ready. This is where you will truly start thinking in objects. See you in lesson 2.